Now take the next one, that is called as a graphical method of LPP. Graphical method. What this name implies is that is, you have to get an optimal solution of any LPP problem by plotting a graph. By plotting a graph. Graphical method means what? You have to obtain a LPP solution which will be an optimal by plotting a graph. In this graphical method, you have to plot the graph within an x-axis and y-axis, right? Within a two axis, you have to mark a region which will be feasible for the optimal solution, and you have to find the value of objective function, right? Now, when the graphical method is more efficient, when there are only two decision variables in your LPP problem. When it will be more efficient, when there are only two decision variables in the objective function. And what is an objective function we learn about? That is either mean or max z is equal to c1 x1 plus c2 x2 plus dash 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 plus cn xn. But that will be not applicable here. Here, when this method is going to be used when there are only how many variables will be there? Only two. Means either x1 or and x2. If there are only two variables, then we can use a graphical method to get an optimal solution. Clear, everybody? Now, little bit you have to study about the graph, right? Everybody knows that this is always, we can say that it is in first quadrant, right? This one is in second quadrant. This one will be our third quadrant, and this will be our fourth quadrant, right? And everybody knows that this value is always what? Plus plus. This one minus plus. What about this one? Minus minus. What about this one? Plus and minus, right? This is a general we can say signs of an quadrant, right? And in graphical method, very important concept you have to keep into the mind that you have to plot a graph. You have to get an optimal solution by plotting a graph in first quadrant only. In which quadrant you have to plot the graph? It's very important. In a first quadrant, you have to plot the graph. You have to mark a region, feasible region to get an optimal solution. This is the very first rule of a graphical method. What is the first important point I told you? That you have to plot the graph. For that, only two decision variable must be in the LPP problem. After that, your graph must be in the first quadrant, right? First quadrant is always plus plus, right? Sometimes your coordinates will be a negative. Sometimes your coordinates will be negative. But you have to mark the region in only first quadrant, right? Clear, everybody? Okay. Now the next important point regarding the graphical method is that now we learn what is the general form and LPP problem, right? And here in a graphical method, generally LPP problem is having a very standard conical form is there. See here. Suppose if my objective function is a type of max z, It's a max z. If my objective function is a type of max z, then even constant should be less than and equal to, and what are the variables? Decision variable must be greater than and is equal to 0. This is the conical form of an LPP. Means what? If it's a max j, my objective function is the type of max, then constant should be less than. Getting what I am saying? This is a conical form. Conical form is a standard form. If my objective of max, then constant should be a less than. Now, the another one is called as my objective function can be a type of min z, can be a type of min z. And if my objective is type of min z, then my constant should be greater than and equal to. And all decision variables and all decision variable must be greater than and is equal to. This is the second possibility that LPP can be, right? But first saying that this is the conical form, we are going to learn it in the duality of an LPP. So if it isn't like this, then we can say yes, it's in a conical form, means it's in a proper form. But every time it is not going to happen like this, right? The third possibility can be in the LPP, that is my objective functions can be type of mean or it can be a type of max, right? That doesn't matter. It can be a mean or it can be max, and my constant will be type of mixed constant. Now see here, it is a mix. One is less than, another one is greater than, again less than, greater than, like this. It is called as a mixed type of constant, and my all decision variables should be greater than and equal to 0. Should be greater than and is equal to 0. Now, these three types of problems in the graphical method can be solved. Fine. Which are that? One is called as a max constant should be less. The scenario will be different. If my function is type of mean constant is greater than, scenario will be little bit different. And my objective function can be mean or can be max, and all constraints will be mixed type. Now, keep in mind, if my scenario is like this, then what is the possibility? Suppose this is my x1 variable, this is my x2 variable, right? And suppose there are the three equations are there. For example, these are the three equations. We assume that, right? What is the equation we will see later on. But suppose after what the LPP problem is given, and in the algorithm there is one step that you have to find out the coordinates. And once you find the coordinates, you have to plot a graph. And if you plot the graph, later on you have to mark a region towards 0 in a such a way that all equations are touched to that region at least one intersect point. Getting what I am saying? This will be not a valid region, this will be not valid, this will be not valid. Even though in all these three regions, my all equations are touched, but we cannot mark that region. Why? Because my given problem is type of max and all constants in the conical form, right? When such types of scenarios to be occur, my region must be towards what? 0. And you have to mark this region in such a way that all equations must be touched to at least one intersect point. Clear? This is my first possibility, first type of nature. You will get an optimal solution by this way if my given problem is like this. Okay? In a second one, if my objective function is a minimized type, then it should be all the percent should be greater than 0. In this case, what will happen here? Suppose this is my first equation, this is my second equation, and for example, this one is the third one, right? Where is my origin? Original. This is my original, right? 0, 0. Now, in this case, it should be towards the 0 in this case. But in this case, it should be completely opposite to the 0. Means my optimal solution or my feasible area should be completely opposite to 0. And by using these coordinates, you have to find the optimal solution. And which points I have to consider here? These are the 3 points. By using these 3 points, I have to solve the problem. Here, see, means the always first step will be what? Find the nature of the problem. If in the method, if my problem is type of graphical, max and all constants are less than, then my solution should be like this. My graph and my result should be completely towards the 0. If my problem is type of minimization, we have to observe whether all constraints are greater than or not. And if yes, then you have to plot the graph, but your result should be completely opposite to the 0. Clear? Now, third one. What is the third one? That is, your objective function can be mean, right? Can be max, right? Then can be mean or max, or constant can be a mix. Now here you have to plot a graph. For example, again there is an one more area is there. For example, one equation is there, right? In this case, where you have to plot the graph. Now it is a not a mean or it is a mean or max, that doesn't matter. But constants are mixed. Constants are mixed. The here it should not be completely towards the x-axis or it should not be completely towards the y-axis. It should be somewhere else that will be not either towards the 0x or 0y. So your result should be somewhere like this, where all equation must be touched at one intersect point. Clear, everybody? Getting the important thing. If this concept is clear, then you can easily find out the solution of any problem by using the graphical method. What's important is that you have to find the nature. If it's a max and less than, your region must be towards to the 0. If it is a type of mean and all constants are greater than, then it should be completely opposite to the 0. And if it can be mean or max, but my constants are mixed, it should not be completely towards this 0 x-axis, or it should not be towards the y-axis, means 0 should not be in anywhere in the solution. The region should be somewhere else. That is not touch to the 0 line of x and 0 line of y. Clear, everybody? And these 3 types of problems can be you have to be solved and get the optimal solution. So these 3 scenarios, okay, where you have to use the graphical method, where there are only 2 decision variables are there in the solution. Find